Welcome to DevOps Project Live Implementation Project Hospital Consultancy Booking Portal. So, a moderate and scalable healthcare application on Azure. So, technologies we are using Azure Kubernetes Services, Azure Container Registry, and Azure based MySQL. We will using a Docker file and Kubernetes manifest. So, for front end and back end of development, we are using React.js and Spring Boot, and we are using Terraform for Azure infrastructure automation. So we are using Azure DevOps. Okay, thank you. Till now we have completed three projects. This is the project for Hospital Consultancy Booking Portal using AKS, ACR, and MySQL. Let's see. Codes for you. Hospital Consultation Booking Portal, a cloud-native appointment management system. So this project is a web-based healthcare platform that designed to simplify the appointment scheduling between patients and doctors. Okay, this part helps users to allow to book and manage the appointments through online. That will reduce the manual work and improve the hospital efficiency. Goal to build a secure and scalable and reliable hospital appointment management system that leverages the Azure Cloud Native services for higher performance and easy management. Okay, easy maintenance. So it is a three-tier application. It having the front end, back end, and DB. Let's see the application. Let's see the front-end application. It is developed using React.js. So application is going to compile and build. So it will be start the application automatically. Okay, let's see. Here we go. So welcome to AST Hospital, a healthcare portal for hospital only. Okay. So this is the welcome page. They're having multiple tabs. Okay, home facilities they have. They will providing the all the details of facilities. Doctors they are having, branches they are having, about us, and book consultations. Okay, after that consultation. Okay, so this application is designed for booking the appointments. Okay, so we need to provide the details. Okay, something you can book. You need to pass the patient name, you need to pass the age, contact details, doctor, and the date of booking. Okay, so reason and symptoms. Okay, you try to click book so that all the consultations will be able to see here. Okay, once the booking is confirmation. So this is the front end application. So backend we already developed. So till it is moved to the cloud, we are not able to see here. This is a local development. So let's see how to build and deploy end to end from front end to back end to DB. Okay, Azure services and DevOps tools we are going to use. So key highlights. We will use a front end. So we will need to develop the front end application using React.js. Okay, so that will helpful for interface with the users. Okay, backend. So we need to develop using Spring Boot application. Okay, so we have database. So that will be store the data of patients, doctors, and appointment dates. Okay, we are using Azure MySQL. Okay, so containerization. So we will pack our applications as images and it will be stored in Azure Container Registry. Okay, so deployment. So we will scale automatically using Azure Kubernetes Services, and for this purpose we are using Infra and CI/CD pipeline. Okay, so VNets. So we will use a VNet to secure the connections between AKS and MySQL. Okay. So we will use the Azure DevOps. We will use Azure repository and Azure pipelines that will trigger the pipelines. Okay. We will use the Terraform that will provision the Azure infra. Okay. Let's see. So we have Azure Container Registry, we have Azure DevOps, and we have Azure Kubernetes Services, we have MySQL, and we have Nginx load balancer. This also we need to create. So let's see about how we are going to implement this one. I will explain you this architecture and workflow also in the upcoming slides. So what you will achieve at the end of this project or this course. Okay, you can able to build and you can able to deploy the front end React.js application on AKS. So same you can able to build and deploy the backend application in AKS, and you can able to write the Terraform script that help for cloud provisioning. Okay, you can able to write the Docker files and Kubernetes manifest. Okay, so we have two type of a manifest, that is front end and back end. You can able to write the Docker file and Kubernetes manifest for front end and back end. So after that, you can establish a secure connection between front end to back end, then to MySQL DB. Okay. So after that, you can able to learn how to create Azure pipelines for your CI/CD automation. So we have five type of pipelines. Okay. So with this, you can able to deploy your real world DevOps project for your portfolio. Let's see. Hi. Before going to implementation, let me introduce about myself. I am Prasanna Kumar. I have overall 15 years of experience in IT industry. So I have worked on multiple DevOps roles. So currently I am working on one of the top most MNC company. And also I have working experience in different kind of projects. So that is banking project, automobiles and travels and transport. I have medical care field experience. I have telecom, and I have worked on big four companies also. Okay. So I have multiple certifications. So most important one is AWS DevOps certification and Azure DevOps certification, and the base fundamental cloud certifications like Azure fundamentals, AWS fundamentals, and etc. So let's see the architecture and workflow. Architecture and tech stack walkthrough. So let's discuss about architecture of this project. Okay. So you can see the picture of the architecture. Okay, architecture of hospital consultancy booking portal. Okay, it having multiple components. Okay, if you are not able to see this picture clearly, I will open in a separate page, separate photo. So okay, you can see. So you can observe multiple components. So you have Azure DevOps, Azure pipelines, you have container registry, you have managed identity. So you have VNets, and you have subnets, and you have subnet. This is the MySQL. So you have Azure Kubernetes Services, you have pods, and we have services, and we have front end and backend. We have Ingress, and we have Nginx load balancer, and we have Helm. Let's discuss each one separately. Architecture of hospital consultation booking portal. Okay. So you have seen multiple components, right? So let's start from here. So we have a developers. They will develop the front end and back end application. So they will, once the code is ready, they will commit and push the changes to Azure repository. And in Azure DevOps, we have Azure pipelines. Based of configuration, the pipeline will be triggering. So this pipeline is having a secure connection. Okay, that will establish a secure connection between Azure DevOps and Azure portal. Okay, so we have multiple pipelines. We have pre-infra pipeline and infra pipeline and CI/CD pipelines for both front end and back end. Let's see each pipeline. So these infra pipelines based upon the Terraform tasks. So that will be provisioning all these resources. Okay, it will provision Azure Container Registry. It will provision subnet. It will provision VNets. It will provision AKS. It will provision MySQL DB also. Okay. So once the all the resources are completed, so now we need to create a Nginx load balancer. So we have a another pipeline Helm installer, and it will install the Nginx load balancer. Okay. So once the load balancer will be installing, so now come to CI/CD pipelines. So in the CI pipeline, so the application will be back and shipped to Azure Container Registry. Okay, all the images will be stored here itself. So front end and back end both will be shipping the Azure Container Registry. Now CI is completed. Now come to CD. So in the CD pipeline, so we need to deploy these images to the AKS cluster. First of all, we need to deploy these components. In the CD pipeline, we have a Kubernetes manifest. So we need to deploy this all manifest in the AKS cluster. So once we need to deploy all the clusters, then we need to update with the latest image of your front end and back end. Okay, CD pipeline will be taking latest image from ACR and it will be deploying in the Kubernetes services. So with this, all the applications will, all the components will be deploying in AKS. So when try to pulling a latest image, so it requires some permission. Okay, so we have RBAC. We have created a role so that having the managed identity that will pull the latest image, okay, and update in the Kubernetes services. So like this, the workflow will be changed, continue. Okay, so we have front end users, so they will try to hit the public API. So we have public API from Nginx load balancer. So you can configure this public API. So based upon your organization, once the you configure that address you can hit in anywhere. So like address like www.apollo.com, www.astra.com, like this. Okay, you can configure. So the traffic will be flow from front end user to here, so it will route to ingress. You have two ingress paths. By default, it will go to front end services. So you have backend services. When patient try to book, it will route the traffic to backend services. So backend will be process your data and store in the MySQL. So we have established a private DNS for this MySQL. So it will come from subnet to this subnet. So the communication will be happening from subnet to subnet. So with the help of a private DNS. Okay. So this MySQL will be not accessible publicly. Okay. So this is the workflow. So let's walk through what points we have covered. Two, environmental setup. Okay. So there is some prerequisites and tools we need to install to work with this project. So prerequisites. So you need to procure the Azure subscription. So you need to create a Azure portal. You need to log in. You need to create a account, and you need to subscribe. You need to pass some credit card details so that you can able to allow use that subscription. Okay. So once provided, you can able to access the Azure portal. Okay. Let me show the portal. Yeah. This is the Azure subscription. I already subscribed. So this is my subscription details. Okay, this is my forecasting cost center. Okay, so okay. After that, you need to create a Azure DevOps organization. So so this is a simple one how to create. I already show you. I already show you in the previous project. Let me show you again. You go here. So you can create a new organization, and you need to give the organization name. Okay, here you need to give the organization name. So once the organization is created, it should be look like this only. So after that, you can create a project and you can create your own repository. Okay. So after that, two, local tool setup. So you need to download and install some tools. That is Node.js and Visual Studio Code, Git, Maven and Jenkins, Maven and Java 18. Okay. So Node.js will be helpful for front-end application development. Okay, that is React.js application. Okay, so Visual Studio Code is for code editing purpose we will using. So Git, this is a version control tool. It will be helpful for cloning your Azure repository. Okay, so you can make a commit and you can push the changes to Azure repository. Okay, Maven and Java will helpful for to create a backend application, that is Spring Boot application, and I will show you how to create the Spring Boot application with the help of a initializer tool. Okay, after that, three, Azure Pipeline Agent. So this is the optional one. So if you are using your Microsoft its own pipeline, so you don't need this one. So if you are going to if you are using your own pipeline, so you need to follow that one. So for that first, you need to create a virtual machine in Azure portal. After getting virtual machine, you need to go to pipeline agents, agent pools, and pipeline agents. You can download some files, and you need to you need to follow the Azure pipeline agent steps. Okay. Once you will follow that, pipeline will be using that agent will be using as a pipeline agent. Okay. You you can use this pipeline, you can use this agent in the pipelines. Okay. So four, you require Azure service principal and service connection. So this will be helpful for authentication purpose. Okay. So you need to create a, I already show you in the previous project. In the first project, I will show you how to create a Azure service principal and service connection. So I will show you again. So from here, you need to create a service connection. Go to your subscription. Here you need to create a service principal. So I already created a service principal. So you need to create a service principal. So this service principal can be created and it will be attached as a service connection. So go to your project. So here you can add the service connection. Yeah, these are the service connections. So this is my service connection. So this will be acted as a identity. So that allows you to create a resources in Azure portal. Okay. So this will be used in our pipeline. Okay. So we have established it as a service connection and replacing in the pipelines. Yeah. So like this, it will be helpful Azure service principal and service connection. Okay. After that, you need to create a Azure repository. So once you are creating that Azure repository, you need to upload in your local machine and you need to create a front-end, back-end and IAC folders. You need to follow the standard naming convention for these applications and you need to set up a Terraform backend. Okay, this I will show you in the upcoming sessions. Okay, let's see. So let's see the front end and back end and development. 3. Front end and back end and DB development. Okay. So we need to create a front end application and we need to create a back end application. So and we need to integrate the back end to database. Okay. So I already told you. So we are using front end application and we are using back end application. We are using MySQL application. Okay. So let's see how to develop in the locally. Okay. So once you create a Git repository, you need to clone into locally. So once creating, you need to open with the help of Visual Studio. Okay. Let me show you that one. So this is the application I have developed. So it is having front end, it is having back end. So it is having Azure pipelines. This is a infrastructure as a code tool. Okay. So this is the project naming conversation. The standards we need to follow. Okay. It will containing the Azure pipelines. So it will contain the backend application. It is containing the front end application. It is containing the Terraform code. Okay. This is the standard name we need to follow. So let's open this one. Yeah. Yeah, first front-end development. So I already told you how to create the application, front-end application. So since you are using a React.js application, so we need to create that one. So with the help of this below commands, you need to create the front-end application. npm create React app and you need to use your app name. So currently I have given the app name as a front-end only. Okay. So that will be creating this folder. Let me close all the warnings. Yeah, this will creating. So once created, it will having a some default one, that is node modules public src env package log package.json. Okay. So this Docker file and Kubernetes I have created for my own purpose. Okay. Let's see the code. So src we have app.js. This is the important file. So I have developed this React.js application for front end. Okay, for front end view, web view. I already show you how to how to develop. Okay, let me open again. Let me start this application. So go here and click Git. Yeah, ls. So change the editor to frontend. Okay. So npm start. Okay. So this will open your application. This will compile and open your application. Starting. Yeah. Webpack complete successfully. Yeah. See it is opening. Okay. Healthcare patient portal, AST hospital. Welcome to AST hospital. Okay. It is having all the UI. So click each one. Facilities, doctors, branches, about us. Yeah. Book consultations and consultations. So this is the module we are using. So we are using book consultation. So once the patient will be passing all the details like name, age, contact, doctor and the date of appointment and reason and symptoms. Once you click the book, so the data will be taken from this input constraint to backend. So backend will be process your data and it will be stored in MySQL. Okay. So once you click the consultations, here you can able to see the all the bookings of patients. Okay. So currently I don't have my own MySQL in locally. So I will show you in the cloud how to do end-to-end testing, how to do end-to-end build and deploy and test. Okay. So from front end to back end to DB. Okay, this is the application. So we have created our front end application. Now we need to create a back end. So now we need to create a back end. So go here. So how to create a back end application? Spring Boot. I will tell you. There is a website called Spring Boot Initializer. We need to open that initializer. So it will be installing standard project structure. Okay. Instead of you are creating using Maven commands, so it will be throwing some others. Okay, this is the project. You need to use the project name, language, and the Spring Boot version. And here you need to pass the metadata, group ID, artifact ID, name, description, package, and package type, Java version. If you have any dependencies, you can add. So web, you can have web. You can use dev. Okay, db2. Okay. So generate. So this will click generate. So if you click this one, it will generate a zip file and it will download. Okay. So that download file will be unzip and paste in your local directory, local backend. Okay. Yeah. So this will create this project directory. Okay. It having main. Okay. Java com healthcare controller and consultation controller dot java and patient service app dot java. Okay, this is the standard project directory. Okay, I have created the Kubernetes and Docker file. So these two files I will explain you later. Okay, so once you download that file, so it will be unzipping. It will having the form.xml. It having the src folder. Okay, so this is the form.xml where it will be including all parent, group ID, artifact ID, version, and properties and dependencies, the Spring Boot framework, and MySQL drives. Okay, all the dependencies and plugins will be mentioned here. Okay, if you have mentioned any mistakes means so while building it will throwing the error. Okay, so I have tested this application, so it won't get any mistakes. Okay, go to src, you will see the code. So patient service application dot java. This is the entry point for this application. Okay. So now go to controller. This is the controller file. So this file will be, you can see the code. So this is the package. It is importing some Java packages. Okay. So after that, this is the method, this is the mapping, okay, this is the cards, and it is using some DB related things. That means, so it will referring some DB details. It is trying to refer some DB details. So that values will be, it will be fetching and it will process the data. Okay. So this will create a table. Okay. So this will get, so this will fetch the data from MySQL. Okay. So this will post your data to MySQL. Okay. So the whole idea of this application is, so when your data is came from front end, so this will process the data and update in the MySQL DB. Okay. If the DB is not available, it will create the DB. Okay. So this will be create the DB. Okay. This will, so this will fetch the existing data and post it to front end. Okay. Let me show you front end. So, once you click this patient details book, so then once you click the book means, so it will go to backend and this will process the data. So it will connect to the backend and it will we have username and we have URL and password, all the things. So it will be login and it will post this data. It will add your patient details. Okay. So once you click on consultations, so it will be, yeah. So it will go to get get method. Okay. So the get method. So this will fetch the existing data from database. Okay. This is how front backend to we will be connecting. Okay. So my next backend development is completed. Okay. So MySQL interact with backend. Okay. I will tell you how it is done. Okay. So I will tell you how the DB details is fetching. So you can see here. This is the application dot properties where you can able to fill all the DB related details. Okay. So currently I didn't given any original ones. So it will be come from Kubernetes manifesto. Okay. I will show you that one also, how did it will come from. So it will coming from Kubernetes deployment. So when you deploy CD, then when try to book the patient, then you will be taking that secrets and it will be processing the data. Backend will be processed by the data and you can able to store in the MySQL. Just end to end I will show you in the upcoming slides. Okay. Right now we have completed backend development. Yeah. Next, Docker file development. Okay. So I already told you. So we have deploying front end and back end both in Azure Kubernetes Services. So in order to run your applications, we make this application as a container environment. For that purpose, you need to make these applications as a Docker images. Okay. So you need to write the Docker file. So that file will be building and storing in the Azure Container Registry. Okay. So after with the help of CD pipelines, so these images will be deploying in the Azure Kubernetes services. Okay. So like this, you can able to access. So once the deployment is completed, the application will be access to the public IP. It will be accessed by the global users. Okay. Let me show you how we have it in the Docker files. Yeah. So each I have front end and back end. So both Docker files will be written in the base directory of their applications only. So let's start with front end. Okay, this is the Docker file. This is a multi-stage Docker file. It having the two stages. One is build the React app. So two is serving it as a Nginx. Okay. So this will be helpful to build your application. Okay. So using Node 18 and work directory slash a app, we are copying package file, we are installing. After that we are copying whole application. After that we are exposing React app API base. Okay, these are some environment variables and arguments. This currently It is not a most important. Okay. So after that, run npm run build. So these command help us to build your application. Okay. It will generate a artifact. So that will contain a slash build, that will contain under slash build. Okay. So just remember that one. Okay. Now, so building the React app application is completed. Now come to second stage, that is serve with Nginx. Now we have artifact. Okay. Now we need to run this application. So in order to run the application, we are deploying this application in Nginx. Okay. So that application will be up and running. Okay. So now React app will be served with Nginx. Okay. So we are using Nginx and we are removing unnecessary files, and we are copying from stage one. So this is the build. So front end is first stage is started as a build. From there we are copying this one. So this command will generating a slash app slash build file, and we are copying that one. We are pasting in this specific location where Nginx is running. Okay. After that, we are exposing node 80. After that, we are running the Nginx. Okay. So wherever we are storing Nginx slash HTML, here we need to use the base location for application run up and running in Nginx. Okay. Simple. So the application is just copy and pasting in the Nginx, so that the application will be serving Nginx. It's like just Nginx only. Okay. This is the Docker file of this front end. Okay. Now see the Docker file of backend. Yeah. So even this is also having a two multi-stage files. Okay. Stages. So first one is using build app. Okay. This will generate the build artifact. Okay. Two, it will be served as a application. Okay. I will help you. So from this one we are taking as a base image and image treated as a build name. So this is the working directory. This is the this we are just copying the form.xml. With the help of form.xml, we are just installing the dependencies with the help of maven command. Okay. After that, we are copying the source file. Once the source files are ready, so we are packing our application mvn clean package. So we know the 6 steps of maven, right? So mvn clean install, mvn compile, mvn deploy, mvn install, mvn spring boot slash run, like that we have, right? Yeah. So this is the one of the command, that one. Okay. So once the package is ready, it will generating the artifact. Okay, like a target dot some jar file like this. Okay. Once it will generating the artifacts, so now we need to serve it as a application. Okay. This help us to serve it as a application. So we are using this image. So we are using the working directory. We are copying from the build stage to here. Okay. We have some jar files in target, that whole artifacts with copying with as a app.jar. Okay. Only single app is available. The same we are taking app.jar. So we are exposing 8080 app. Once the application is started, it will be passing this command. That means once you deploy this Docker image in the AKS, so it will be started running with this command. Okay. Yeah. So this is all about Docker file development. Okay. So now come to Kubernetes manifest. Okay. I already told you. So we have two applications, that is front end and back end. So in order to run the application, we need to deploy using Kubernetes manifest. You can also deploy with the help of a Helm charts, or else you can also deploy with the help of commands also. So currently I'm just going with Kubernetes manifest only. Okay. So with the help of a pipelines, I'm going. So I need to develop the front end and back end manifest. Okay, let me show you. So let's come from front end. Let's see the Kubernetes manifest. Yeah, this is the Kubernetes. deployment.yml. Okay, this is the service. Okay, this part, this is the front end, this part. Okay, this is the deployment. We are having the deployment, we are having the replicas, and this is the selector, and this is the template. Under template, we need to pass the container specifications. So this is the image name, this is the container code. So this image name cut from ACR. Okay, we already tested, so that I just updated the name as it is. So if you don't have, so once the infra is deployed, you will get a image registry. So you can paste the image registry here. Okay, so the front end name, when you are trying to build, so whatever name you have given in the CI pipeline, that name can be, you can give here itself. Okay, yeah, this is the deployment.yml. Now come to service. This is the service. So in the service, we have cluster IP, the selector is front end, and ports are 80. Okay, that means, so the port will be acted as a cluster IP, which will be accessing internally, and the port open is 80. Okay, yeah, here you can see we have front end React application, and we have two replicas. We have one service which will be acted as a cluster IP. We have opened the port 80. Okay, yeah, this is all about front end React.js. Okay, now once completed this front end thing, we need to install this part. Okay, I will tell you that back end also. I close that one. Open deployment.yml and service.yml. I will show you all the things. This is the deployment.yml. So where you need to pass the replicas to, and you need to pass the selector, and after you need to pass the metadata. Under specifications, you need to pass the container details. Here you need to pass the registry. After that, you need to give the container code. After that, you need to pass the environmental variables. Okay, so these environmental variables will be injected in the application. Okay, so I'm just passing the Spring Boot URL. Okay, this is the Spring Boot username. This is the inputs Spring Boot data. Okay, Spring Boot password. Okay, so these all details will be injected in the backend application. Okay, so these details will containing the MySQL username, MySQL URL, MySQL password. Okay, so this is the config mag reference key. Okay, where all details will be saved in config mag. Okay, it is just a reference only, and this is the secret key reference. Okay, where secret will be storing with the name of this one. Okay, let's see. So we required a config map and we required a secret. Okay, so we have created a secret. This is the secret. This is the config map. So in the secret, we are storing my MySQL password. So for to integrating the backend to DB, we are using this password. While creating infra, it will be generating the same I have pasted here. Okay, so there are multiple ways to store your passwords. So, but I'm going with this approach. Okay, there is a key vault approach also is there. So for key vault approach, I have created one different project. So you can, that will be, you can see later. Okay, so this is the config map where your configuration of your URL and username will be storing as a config map, and it will be referring in the deployment. Okay, deployment environment variables. Okay, now come to service. This is the service. We are passing the selector and port and cluster IP. That means, so it will be acted as a cluster IP. It will be accessible internally, and the port open is 8080. Okay, let me show the architecture. Yeah, you can see here. So we have deployed front-end application, we have deployed back-end application. The back-end application, we have a DB details that will be try to interact with backend to DB. Okay, so we have Spring Boot application name, we have username, we have password. So that will be we are saving the secret and config map. Okay. So once the application is up and running, it will be hitting from backend to so subnet, from subnet to the subnet, and here we can able to access. For both purpose, we have generated a private DNS, so that will be help us to communicate with both. Okay, let's see how we have. So we will discuss more about this in Terraform code. Okay, okay, that is all about Kubernetes manifest. So let's go to Terraform code. You can understand better how the integration is happening. Okay, so we have deployed both front-end and back-end Kubernetes manifest. So now we need to deploy this one. So this is the ingress, okay, ingress part. So this will help you route the traffic from front-end to back-end. Okay. So in order to install this ingress, you need to install the Nginx load balancer. Okay. So I will show you how to install in upcoming session. Okay. Now see the content of the ingress. So ingress.yml. Okay. So you can see this one ingress. You need to pass some annotations. Okay. Important annotation. The host you are using is this one. So currently we don't. I don't have real DNS name. So I am using this one. Okay. Okay, it will be routing your traffic to directly to your front end. Okay, so by default it will be routing to backend. So this is a empty path means dash, so it is a empty one. So once it will the traffic will be routing to front end. So when the patients will try to book, so then the route will be go to consultants. Okay, front end to back end. Okay, that like this the routing will be happening. See, you can see here. So we have users, global users. They will try to hit the public IP. So they will able to the traffic will be moved from public IP to ingress pod, where we have installed Nginx load balancer. We have ingress. So ingress will having the two paths. The traffic by default will be routing to front end. So the users will be able to see the front end application. Okay. So when the patients will try to book the appointment, so they will hit the slash API. Okay. Here in our case, it is a consultation. So when we will try to hit that one, then the traffic will be routing from front end to back end. Okay. It will come from front end to back end. So back end will be process your data and it will be storing in MySQL with the help of a private DNS. Okay. We established a service connection between front end and back end. Okay. Yeah, let's see the Terraform code so that we can know better understanding how the integration is happening between MySQL and this subnet, AKS subnet. Okay, let's go walk through the Terraform. 4. Infrastructure as a code, Terraform. So first we will write the Terraform code for provisioning the Azure Infra. Okay. After that we organize the infrastructure as a code project structure. Okay. I will explain you how to do the project structure Okay. So after that we need to configure the Terraform backend. So in order to store your TF state files, you need to create a Terraform backend. So you are using storage account for Terraform backend. Okay, I will show you how to do that one. So after that, you need to get the Azure service install and establish the service connection and utilize in the pipeline. Okay, this is a part of a environmental setup. This is the prerequisite step. So we need to create a Azure service install and we need to add it as a service connection. Then we need to utilize in the pipeline so that your Terraform task will be executing. Okay, that means we should have a managed identity that will having the permission to deploy the resources in Azure portal. Okay. Okay. After that, we can deploy using Azure pipeline. Okay. We have multiple pipelines. We have pre-infra pipeline, infra pipeline, and of course we have cleaner pipeline also. That will be part of a last step. Okay. Once the steps will once you are deployed, so all the resources will be creating. Okay. After that, we need to verify the services whether the required services deployed or not. Okay. Let's see. Yeah, you can see the architecture. So we require the components like Azure Container Registry. We required this one. We required VNet. We required subnet, two subnets. We required AKS cluster. We required Nginx load balancer. We required MySQL. So these all things we need to require, and we required a one role that pull the image from ACR registry. Okay. So let's create the Terraform code. So I already created. We just review that code. Go to ASC folder having dev, pre-request and prod. Okay, Azure commands that will be using while deploying. Okay, so for your reference purpose, I am showing you. Okay, so we have main.tf, output.tf, provider.tf, and variables.tf. Let me walk through the code. So we need to split the Terraform into two parts. So part one. So we will create these two parts in a pre-request pipeline. So we will create this part in infra pipeline. Okay. So in the pre-request part, we will create a Azure Container Registry and resource group. Okay. In the infra pipeline, we will create a Azure Kubernetes Services, and we will use and we will create a MySQL, and we will create a subnet and VNets. Okay. And also, of course, we will create a RBAC role. Okay. With the help of a infra pipeline. Okay. Let's see. Yeah. Go to pre-request. Okay. This is the code. This is the locals I given for naming conversation purpose. So this will create your standard name. Okay. So it will be taking from project, application, environment, and location shortcut. Okay. It will come from variables purpose. This is the values, only variables. So we require the key values. Go to the terraform.tf path. This is the key values, project, application, environment, location chart, and block code. So this is for most of the products are using block code in IT industry. So that I have taken the same tag. Okay, block code, unique ID, server ID, like this. They are kept on multiple tags. Okay, so this the tags will be taken here itself. Okay, so this will create a resource loop on container registry. So move forward. So after creating the container registry and resource group, now we need to create a Kubernetes services, subnet, and MySQL and VNet. Okay, so let's see. Yeah, this is the code. Okay, from starting onwards, this is one. Okay, these help us to fetch the data of created resources. So this is the resource you have created. This is the resource group and container registry. Okay, it will be fetching the data with the help of a data command. Okay, so that data will be utilizing the upcoming resources. Okay, so here you are creating the virtual network VNet. Okay, so see how data is fetching from existing one. Okay, like this you need to use. Okay, after that we need to create a subnet. It will be utilized by the AKS. Okay, so after that we need to create a subnet. It will be utilized by the MySQL. Okay, so till now we have created resource group, Azure Container Registry. We have created Azure Container Registry and the resource group, and we have created VNet. Okay, we have created VNet and we have created subnet. This is the one subnet and this is the other subnet. Okay, so now come to MySQL part, MySQL and MySQL database. So we need to create a MySQL server first. Okay, so this will help to create the MySQL server, and this will be used for Azure login username and Azure login user password. Okay, so DB user and DB password. So I have given the password in the variable section. We go this dev, where dev dot key values I have mentioned. So this is the key name, admin password. Okay, it will be referring and it will taking. Okay, The same key values you need to give in the Kubernetes deployment manifesto, so that the backend, this MySQL will be interacting to the backend. Okay, this is the okay. So you need to pass story values, SQ version, and MySQL server version. So after that, we need to integrate it with the subnet. So this will help us to integrate to subnet. Okay. So now the MySQL server is ready. Now we need to create a one database. Okay, the database is this one, healthcare DB. We have created the healthcare DB. Okay, so this for AKS SSH key. Okay, this is auto generated one. So you don't bother about this one. Just leave this one. So now we need to create a Azure Kubernetes cluster. So we have created a MySQL server. Okay, now we need to create this part, AKS part. Okay. Yeah, you need to use this command. You need to use the resource Azure Kubernetes cluster. Okay, so this will help us to create a Azure Kubernetes cluster. Okay, you will create a sub node. Okay, under that all the pods will be deploying. Okay, so you need to give name, location, resource group, or DNS prefixes, and node resource group. Okay, this will create a separate node name. Okay, internally. Okay, it won't. It is not a very important. You can give any name also fine. Okay, so this will create a node. Okay, it will contain node count is 2, and the VM size is this one, and we need to integrate this node with VNet subnet. Okay, so we need to manage it as a system assign identity. Okay, that means, so what are the system is assigned, you can take that identity only. That means, so system will be creating some identity like service principal. When they are try to communicate with this AKS cluster, you can use the same identity and work with that cluster. Okay, it is related to network profile. So you can use this is as a default profile. Okay, it will use some CIDR and it will use some details. Okay, network policy detail. Okay. After that, you need to pass the login Linux profile. Okay, you need to pass the username and password. Okay, after that, you need to enable the RBAC. Okay, we have enabled the RBAC. Okay, with this, you will be able to create a AKS cluster it will be creating. Okay, so AKS having a capable of managed identity and it having the RBAC. That means whoever having a managed identity access, they can able to work with AKS. Okay, so move forward. So we are creating a role. So that is AKS ACR full role. That means this role help us to pull our container image from container registry to AKS cluster. Okay, so if you need to work with any deployment, you should require the image. So for that purpose we need to pull from a Azure container registry. So we need to create some role. To pull that role, we are creating this role. This role having the capability to pull. Okay, so it will use my own identity. Okay, so after that, we need to create a network role. Okay, so this having a capability of accessing from external resources also. Okay, it also using our own principal ID. Okay, network contributor. So you have subnet. So that subnet should be having a role, and this role should have a access of my own identity. Okay. So after that, you need to make a DNS setup for your MySQL part. Okay, this is the name of your MySQL. Okay, that will be creating a DNS and it will be integrating to subnet. This part will be integrating to subnet. Okay, so let's see that one. Yeah, this is the MySQL. So it will generate a random DNS name. Okay, not random. So DNS name. So that DNS name will be help to connect to the backend. Okay, the AKS cluster. So for that purpose, we have created a role. Okay. Here we have created the role network AKS network contributor role. So it will help us to communicate with your AKS to MySQL. This is the our code. So now our code is ready. So project directory is this one. So dev pre-request prod. So dev it will containing the dev.tf tfvars and backend.tf means it will having the Terraform backend details. Okay. The same vice versa for prod also you can have prod details. Okay. So after that you have main.tfl, output.tf and provider.tf. The provider.tf you need to give the subscription your own subscription name. Okay. So you need to pass the Terraform version and Azure version. Azure version you are going to use. Okay. This is the variables you need to give. Okay. Now we need to create a two pipelines. One is pre-infra pipeline, another one is infra pipeline. So this implementation we are going to see in upcoming session. 5. CI/CD pipeline with Azure DevOps. Okay. So we need to set up the YAML based Azure pipelines. Okay. Since there are many types, but we are going with YAML based only. So you can able to create manually also, but I am going with YAML based. Okay. 2. So we need to create a pipelines. We have multiple pipelines. So one is pre-infra pipeline, infra pipeline, ingress pipeline, front-end pipeline, back-end pipeline, and cleanup pipeline. So pre-infra pipeline. So this will be provision your pre-request resources. Okay. We have ACR and resource group. This will be provision. Okay. With the help of a Terraform task. Okay. Infra pipeline. So this will provision remaining all resources. Okay. We can see. Yeah. Yeah. The pre-infra pipeline. This will provision this part. Okay. Azure Container Registry and resource group. Okay, infra pipeline will provision this part. Okay, container services, subnets, and MySQL. Okay. After that, we have ingress pipeline. So this will help us to install Nginx load balancer using Helm chart. Okay, I'll show you that one also. After that, so it will be generating a public API. After that, with the help of a front-end pipeline, you need to build your application and you need to ship your Docker image to ACR. Okay. With the help of a deploy stage, it will be deployed to the AKS. Okay. Kubernetes manifest will be deployed in AKS. After that, image will be updating so continuous process will be continue like this. Okay. After come to backend pipeline. So the same, it is also build your image and it will be tagging as a Docker image. It will be publishing to ACR and with the help of a deploy stage, it will be updating the Kubernetes manifest and it will be updating the Docker image and it will be deploying latest changes. Okay, like this we need to set up the backend pipeline. So once all the things are completed, after that, we need to clean your all resources. You need to delete all resources with the help of a cleanup pipeline. This will delete all the resources. We can see this pipeline at the end. Okay, let's start. Yeah, let's go to Terraform. So now we will start with pre-infra pipeline. So now the implementation started. So we have pre-infra pipeline. Okay, this is the pre-infra pipeline. So let's walk through this infra pipeline. So it will containing the variables pool and trigger. I will trigger him manually only since it is infra part. Okay. So this will help us to create a to install a Terraform. If it is not available, it will install. If it is already existing, it will get the Terraform version. Okay. So two. So this will initialize your Terraform. Okay. Next three. So this will validate your Terraform code. Okay. 4. So this will plan your Terraform. Okay, Terraform code. Okay. 5. So this will deploy your actual Azure resources. Okay. So let's deploy this. This is the infra pipeline. So next, pre-infra pipeline. Okay. The difference between infra and pre-infra is only location changing. Okay. It is using IAS folder. It is using IAS slash pre-infra. Okay. Rest of the things are same. Okay. Let's go. Let's deploy one after one. So first we can deploy pre-infra pipeline. This is the pre-infra pipeline. So go. So let me commit the changes. What I have done. Okay. These are committed. So I have done some changes. So this is my hospital consultancy repo. Okay, it looks fine. Let's check the pipelines. So currently I don't have any pipelines. Let me commit the changes and trigger the pipelines. Okay. So the naming convention will be very good. So should be exactly. So that will understand the others also. Okay. Like it, we need to commit and we need to push the code to repository. Okay. Go to repository. You can check the changes. Go to files. Go to commits. So added changes to front end. So if you click that one, so it will open what are the changes I have done. Okay, it is front end changes. Okay, leave that one. Now come to pre-infra. So this is the common steps. Okay. Go to pipelines. Create your first pipeline. Okay. You need to select your hospital image. So since I have already existing YAML, so I use this one. So if you are going to go with manually, you can click this one. Or if you want to create a new pipeline, you can click this one. So I have already one. So click that one. So before that, you need to select the pre-infra. So don't confuse. Click the exact one. Click that one. Okay. So click run. Just review and click run. So it will take time to pull the email, to pull the Microsoft agent. Okay. So I already told you if you need some your own pipeline agent, so you can install the VM and you can utilize here. Okay. Yeah. So it will be do this one. You can rename this one pre-infra. So you can check the logs. So first, so this step will install the Terraform version. Okay. So if you are using a pipeline agent, it won't do again and again. So since you are using a Microsoft agent, so Microsoft will allocated unreserved agents. Okay, that means each and every build or every pipeline you will get a different pipeline agent. So that times what it will happen, it will be installing each and every time. So the Terraform will be not available, it will be installing. Okay. So now second step 2, Terraform initializing. So it will initialize the code, initialize the backend. Okay, okay. Terraform backend is completed. So 3, Terraform validate. Okay, this will validate your Terraform code. Next, Terraform plan. Okay, so let's wait some time so that it will be all the resources will be creating. So now the pipeline is completed. All resources are completed. Okay, resource group and container registry is created. Go here and just cross check. Just refresh this page. Sometimes it will take some time to create to reflect the resources. Yeah, here we go. So this is the naming conversation: healthcare, patient, portal, dev plus RG. Okay, this is the RG. This is the container registry. Okay, click that one. You can check the container registry details. Okay, it is just created. Okay, now what we will do? We will create a infra pipeline. Okay, so go the portal, create the infra pipeline, and wait some time. It will take a lot of time to create. Review and run. So you can rename this one. Infra. Okay, use the simple words so that it will understand all members. So these are pipeline. This is the pre-infra pipeline. This is the infra pipeline. So next you can give ingress or nginx pipeline. After that you give the front end CI/CD pipeline. After that you give the backend CI/CD pipeline. Go to infra pipeline now. So this will take a lot of time. Okay. So let me. Yeah. So here, so where can the where can the Docker image will be storing? There is a repository here. So under that it will be storing. Okay. So currently we don't have any images, so it is empty. So once we will do CI/CD, then we can check the images. Yeah. So Terraform task has started. Yeah, Terraform is installed. Okay. So now Terraform is initializing. Okay, it is validating. Initializing and validating. Okay, plan. So this will take some time to create. Once come to Terraform apply. So around 10 minutes it will take to create. So we have AKS cluster and we have MySQL server, right? So this will be taking some time. So this is the Terraform plan. Okay, it will show you what are the resources to create. It will create the Kubernetes cluster. It will create the MySQL server and MySQL database. So these create the private DNS. Okay. This create the AKS ACR role. This create the AKS network role. This create the subnet, AKS subnet and MySQL subnet. This create a VNet. This create a SSH login for your AKS. Okay. This is the temporary one only. So it will be deleting once the pipeline is completed. Let's wait for creation completed. You can observe the logs of your resources. Here you can see AKS and AKS and MySQL server is taking a lot of time. The pipeline is created successfully. So all the resources are created. Okay, it is taken 7 minutes. So apply completed. Apply 11 resources are created. You can see. Okay. MySQL server, MySQL DB, AKS ACR full role, and AKS network contributor. Okay. Yeah. Let's go and verify all the components. Go to resource group. Let's refresh. Yeah, here we go. So we have Kubernetes services. We have Azure database. Okay. You have VNet. You have container registry. You have private DNS. Okay. So just walk through each one. So this is AKS. Okay. So here is the Kubernetes resources, namespaces. You have default namespace and the rest of the things are, these all are default one only. So all the components which you are going to create, it will be deployed in default namespace only. Workloads, that means deploy and pods like this. Yeah, deploy pods, replica set, stateful set, daemon set, jobs and cron jobs. So deployments, it will having multiple deployments. Our one is, we don't have our one till now. So once you will deploy, our deployment also come here, front end, back end, and then of course Nginx also. Here we have pods. So this AKS will be very slow. So to avoid this one, you can use a CLI part. Okay, that I will tell you in the end of this session. So services and ingresses. So here you can able to see the services. Okay, till now we don't have our one. Okay. Let's move to next one, next resources. Let's go to MySQL server. This is the MySQL server. Yeah, this is the server ID. So you can try to connect this one. Okay, this is the MySQL. You copy this server. So try from external internet. So try whether it is created or not, creating or not. Okay, this is the host name and the database name. So I already given the database name, right? The IAC folder. This is the database name. So also you can check this here also. Same name we will be creating. Okay, this is my database. You can just copying database name and username. This all will be come from Infra only. So DB name. Go to password. Now we will get the password. Dev. This is the password. So copy. Paste. Get test connection. Non-working form. Okay. Non-working form. It is showing it is not able to connect. Okay. So why it is not connecting? Okay. So since it is not publicly accessible, so that we are not able to connect. So if you have access of publicly, so you can able to connect. So we have deployed this MySQL under subnet and VNet. So we are not open these two public. So it will be this MySQL should be connected to backend only. So these details will be already given in the deployment Kubernetes deployment manifest. Okay. So let's go to next component. So VNet, click on VNet. So it will create a two subnets. Yeah, it will create a two subnet. So one subnet is dedicated to MySQL server. Okay. So I don't have any route tables and security group. Okay. These two will be accessible internal only. Okay. So that I didn't join. If you need to access external one, you can able to see here route tables, security groups like this. So not security table, route table you can able to see. Okay. Let's move to next one. So now infra pipeline is completed. Now come to ingress pipeline. Okay. So till now, so we have completed. So this part we have completed. We have created Azure pipeline. We have created Azure content registry. We have completed this resource group. We have completed this AKS. We have completed MySQL. We have completed subnet, both subnets and VNets. So now we need to install the Nginx load balancer. Okay, let's see. Okay, with the help of a Helm commands, we are installing the Nginx load balancer. Okay, so let's see the pipeline. So I created nginx.yml. Okay, so these all are cluster details. These all are cluster details. So where we need to install this Nginx load balancer, we need to pass in AKS only. We need to install in AKS only. So we have given that AKS details, and this is the namespace and this is the ingress release name. Okay, so you can see the steps. Okay, since we don't have access of that AKS outer world, we need to log into that AKS. Okay, so this will log into that AKS. You can see this AKS defined under specific subnet, so it won't accessible outer external world. Okay, so even you have identity, service principal and the service connection, you're not able to log in. Okay, so you should have access of this AKS, then only you can able to log in. So you are passing this command, so this will help us to connect. Okay, after connecting with the help of this command, it will be installing the Nginx load balancer. Okay, so this is the command to add the repo. This is command to update the repository. So this command help us to install Nginx load balancer. Okay, Nginx upgrade, install, Nginx release name. This is the some name we need to give. Repo name we need to give. This is the namespace. Create namespace if not available. Okay, so this is the service type is load balancer. Replica count is 2, and Kubernetes OS is Linux. Node selector is Linux only. Port is we need to open ATN 4434. So this is the pipeline. Let's create the pipeline. Go to pipeline. Okay, pipeline. Yes. I have given the name like Ingress. Okay, if you want, you can give you different one. Install Linux. So okay, so this will install the Nginx load balancer. Okay, this will install load balancer so that public can be able to access the your application. Okay, so once it will be installing, so all the components installation is completed. So only CI/CD part is pending. Okay, let's see. So it will take some time to install. So log into AKS. Okay, here you can see. So it will be logging to your Kubernetes configs. Okay, after that it will be installing Nginx load balancer. Okay. This will be taking some time. Just refresh the page. So Nginx and Ingress Nginx, it is not available. It is installing. once it is installed, go to AKS, just cross verify whether it is created or not. Namespaces. See, a new namespace is created. Ingress Nginx. Okay. Yeah, the pipeline is completed. Okay. So go to workloads. So it will be installing some pods, some deployments it will be installing. Okay. You can see Ingress Nginx controller. Okay. And also it having some pods. Go slowly. It will be with a different name. Yeah. Nginx Ingress Nginx controller. Okay. These help us to route traffic from public to front end. Okay. So with this we have deployed almost all components. Okay. Now we will do only CI/CD. Okay. Let's do. So till now we have completed the infra pipeline. So now we need to deploy the front end application. Okay. Let's go to the pipeline. So front end application. So this will build and publish your Docker file, Docker image to the Azure Container Resources, and we need to deploy using a pipeline. You need to deploy in the AKS. Okay, let's see. Go to frontend.yml file. Okay, frontend pipeline.yml. This is the pipeline. Okay, so this pipeline will be triggering based upon the changes detected in frontend. These are the key values. I already told you this explanation. Okay, so it having the ACR credentials and the service principal it having, and your cluster details and the ACR details and image details and manifesto location and image build image type. Okay, so we have two stages. So stage 1, this will build and push your Docker image to Azure Container Registry. Okay, using it will help this. It will take the help of Docker tool. So this tool will be helping to build your Docker image. This will publish your Docker image to ACR. Okay, so deploy into AKS. Yeah, let's see. So based upon first stage, once it is success, then the deploy to AKS spin up. Okay. So now we need to log into that cluster since we are not having the access, right? So we need to log into that cluster. This command help us to log into that cluster. So now, so we need to deploy our Kubernetes manifest. This command help us to deploy your Kubernetes manifest. This is the location of manifest location you are given in the value manifest dot frontend dot Kubernetes. Okay, it will go to frontend. It will go to Kubernetes and it will be deploying. Okay, Kubernetes apply -f and location. So what are the files it having? It will be deploying. Okay. So once the Kubernetes manifest deploy, so after that it will be setting the image. Okay. So give set image and front end we need to give the ACR image server, image name and image tag. So this image tag will be get from here. Okay. So same image is pushing by the Docker build. So that will be utilizing while deploying. Okay. So let's deploy the front end application. So we need to create the front end. So before that, we need to repeat the credentials to push the Docker image. So this is the Docker push, right? So it will try to push this image. So when pushing, it will asking the credentials. So for this purpose, before that we have login. So Docker login, we need to pass the ACR login server, ACR user, and the ACR password. So we will need to update this one. Go to library, go to ACR credentials. So this name is you have given the variable group only. Okay. Okay. Go to your ACR. container registry. Yeah, access keys, click access keys. So copy login server, username and password. Okay, so copy it. So go here, library, you can update the one. Okay, update, save. Okay, okay, fine. Come to here. So now we need to create the pipeline, front end pipeline. So sometimes it will be lagging. So just refresh the page. Okay, yeah, git. Okay, create. So we need to grant permission for the ACR credentials. Okay, permit. So for first time setup, it will ask you. Yeah, you can rename this one. So front end CI and CD. Okay, so that all will understand that is the front end CA and CD. Okay, just go here. You can observe all the lags. So first is login to ACR. Okay, after that building the application. So Docker image is building. This will take some time. So build is success. So now let's see. So Docker file is built. Okay. So it is pushed into the corresponding container registry. That the image name is frontend. This is the image registry, and the tag is 560. Okay. You can use the tag. So you can go and find in the ACR. Here we go. It is the front end image. Take that one. So image is 560, tag is 560. Okay. So it confirms that it is built and deployed. So go to AKS now. So cross verify whether front end is deployed or not. So for each and every time we need to go to AKS, it is very difficult to us. So we will do one thing. We will do a kubectl installation. Okay. We will work with the CLI. Okay. Click this part. So enlarge this one. I'll give you some commands. You can run that commands to interact with the AKS cluster. So I have shared this in here. Okay. So copy this one. Okay, paste here. This is the interact to cloud shell. Okay. kubectl get all. Okay. Okay. So here we go. So front end is deployed successfully. Okay. Front end is deployed successfully. Okay. So now you can try to access. So where can we need to access? kubectl get ingress. Click that one. So this is the address, this is the host. So we have given the host name as a different. So you can update the ingress address. This is the ingress address. You need to update in the host so that it will be accessible. So go to your code. This is the front end. So this is the ingress side. Copy this one. Yeah, can paste. So since we don't have a specific DNS, so that we are using this one. This is the old one, so that we are using this one only. So NIP added. Okay. Commit and push. Wait for the deployment. So front end is triggered automatically. So I have configured the pipeline like this. When a change is detected in front end, so it will be building and deploying. You need to wait for some time to build. So build is successful. So now go and check again. So it must be updated with your latest name. Okay. So now the name is success. You copy this first. Okay. Hit enter. Yeah. So here we go. Your front end application is built and deployed successfully in AKS. Okay. You can able to see all the things. But your backend application is not deployed till now. So you can't able to book the patient, book the consultancy. Okay. Okay. Let me go to so I have deployed the front end application. So we not deployed the backend application. So the we can't book the any patient. Okay, consultation appointment. So we can go to next process, that is creating the backend pipeline, and we need to deploy that one. Okay, let's see. So now we have deployed front end. So now we can deploy backend. So front end application, front end is completed. So we already deployed front end. Okay. So now we need to deploy the backend pipeline. So let's go to the portal and create the backend pipeline. So let's see the backend pipeline first. Go here. So backend pipeline is similar to front end pipeline. Okay. So we have variables. So you have build stage, you have deploy stage. We will be generating a Docker image. So deploy will be updating with the latest version of your Docker image, so that you can able to access to front end. Okay, let's go. Okay, let's create a new one. Okay, review and create. So allow the permission. Yeah, it will take some time to deploy. Meanwhile, we can change the name. Backend CIN Okay, enter. Go there. So we need to wait for to deploy. So build is success. So now come to deploy. So we need to wait for deployment. Yeah, build is success. Okay, you can go and verify. Yeah, you can see backend is deployed successfully. So all front end and back end is deployed successfully. You can verify each and every component. Yeah. So here you can see front end part is deployed, back end part is defined. So this is the front end part and this is the back end part. So this is the deployment, this is the repo process. So click all. You need to give the full and namespace. So you can pass this command -a, okay, so that you can able to see all components, okay, each and everything. So we'll come from starting onwards, okay. So we have default namespace. Under that we have back and front end, okay. After that we have ingress. It is also installed with the namespace ingress dash nginx, okay. This is a different namespace. So after that, these are the some default pods that will be installed by the Kubernetes only, AKS only. We don't need to touch that things. Okay. After that, front end and back end services are installed. Okay, you can see this is the cluster IP, and ports 80, 8080. Okay. So this is the Nginx. Okay, Nginx controller. Okay, this is installed. So this is generating a public IP. The same public IP we are using. Okay, this is the dimension. This will be creating for default one, default component. So come to deployments. You have front end and back end. Okay, next replica set. So we have front end and back end. Okay, yeah. Let's go to the portal and test. Let's refresh this one. Okay, let's test this one. So till now we have completed. So backend pipeline also completed. So cleanup pipeline we can do at the end of this session. You need to test the end-to-end application. 6. Application deployment and integration. Okay. So once infra application is completed, we need to verify. Okay, we already verified all the resources are deployed successfully, and we have deployed front end and back end to the AKS. We already checked that one. So now we need to verify the integration between front end and back end and DB. Okay, end-to-end test we need to do. So let's go and do that one. Okay. So this is the home. This is the front end application. Okay. Please access this one. Okay. So cube sheet here. Get all. Here all pods are up and running. So let's go and book the patient. So I'm going to, so these are facilities this hospital is providing. So these are the data I have. So I'm feeling a headache, so I need to go to general physician. So the name is Dr. Patel. Okay, I just copied his name. So branches we have this one. So about us, this is the about us hospital. Okay, so then ODI, age we need to verify, contact details, patient contact details, and doctor copied. You need to book the date to book the consultation. Okay, this is consultation symptoms fever. Okay, click order. Okay, now you see consultation booked. Okay, like this you can add a number of items patients. Okay, now so I will add and I will change something details. Okay, 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 consultation booked. Okay, now so now the backend function is working as expected. So let's go to home page, home one. So let's click on consultations. Okay, here you can see. So the patients who are booked for appointments, so here you can see booked consultations. Mr. Is the patient name, age, consultation, doctor, date, reason, and symptoms. Okay. So now with that we have confirmed that front end, back end, DB is worked as expected from web UI. Okay, from front end. Okay, how to verify in back end? Okay, so now all the applications are running. So you can check the logs of each every part. Okay, kubectl logs. Just verify the front end application. Yeah. So somebody is trying to hit the application. So it is showing that get and the hospital name. Okay. This is the DNS name. Okay. So now we'll check the logs of backend. Copy. CTL logs. Paste. Okay. So the now the backend application is up and running. Okay. So now we need to check the data in MySQL. So how the data is processed by this backend. Okay. So how to verify that one? So in order to verify, this is the MySQL part. So this is the DP. So just refresh that one. So how to enter? What are the ways to connect? Okay. So there are multiple ways to connect. But if you try all this one means you are not able to connect. Why? Because they are giving public access, but we don't have public access for this specific one. Okay, we already tested that one. So we need to log into the cluster, then only we can able to access. Okay. Okay. So try to, so right now we already connected to the cluster only. So we can check the, we need to pass the, we need to, there is a one way is there. So you can create a one container, you can try to connect from your local, your mission. Okay, connect to your MySQL. So this is the container, this container will log in. Okay, so and you can test from your local container to MySQL. Okay, so in the diagram already show you. So we already log into Kubernetes. Okay, so we already Kubernetes. So we are already having the subnet. So these subnets can able to connect to MySQL. Okay, so if you log into the AKS means, then we can got the access of subnet also, right? Then we can able to connect to MySQL, right? So we already log in there. So now how to do this? So we can create a container, then we can pass the commands. Okay, so that we can test. Okay, this is the command. So you can paste. I have pasted this one. So click hit enter. So it will try to yeah, it is having the git bash. Okay, after that you can go to given some MySQL commands, you can paste that one. Okay, paste, go here. Okay, paste. Okay, the command is MySQL hostname. This is the hostname of my DB. Okay, so this is the port, this is the username. It is asking for password. So I have my own password. Okay, paste, hit enter. Okay, so now I am able to enter to that host. Okay, so here you can see. So you can pass the some some log queries. You can ask them. So the database. So my database is healthcare DB. Okay, so let me go and run some more commands. Use the command and you show the tables. Okay, okay, we are using the healthcare DB and the show commands. Okay, paste. You have tables like consultation. Okay, let's verify all the things. So get the all the things in the healthcare dot consultation. Wait, the name is wrong. Consultation. Hit enter. Yeah, you can see the entries in the DB. So here this is confirmed that your front-end application is processed by the data backend and it will be storing in DB. Okay. So here you can see, so patient name, patient age, patient contact details, doctor, and the date, reason for coming, the symptoms. Okay, this is the common practices. So now, so with this we are confirmed that end-to-end build and deployment is completed. We have tested from the browser. Okay, we have cross-verified in the database and front-end also it is verified. So now, how can we confirm that if the pod is deleted, how the backend will be processing? Okay, let's see that one also. So I will try to delete one. Okay, let me exit this one. Okay, exit this one. Yeah, kubectl get all. Yeah, so kubectl delete pods. Let me delete all the. Let me delete the backend pods. This is only processing, right, front end data. Delete space delete. Let's see what will happen. Enter. Yeah, two bars are deleted. kubectl get all. So now cross check on. Yeah, backend port is again created. Why? Because this is a deployment, right? So it will be recreating if you delete. Okay. Okay. Now let's see. So this is the page. Let's just refresh this one. Sorry, refresh this one. Yeah, we are in this one. Yeah, here you go. So even backend is even database backend is deleted. So once the backend pod is up and running, then it will fetch the data from DB. Okay. So this is confirmed that even the front end and back end is not there, the data will be backuped in the database. Okay. It is confirmed data is not saving in the pods. Okay. So that's it. So this you confirm that. So application is deployed end to end. Okay. So now we need to clean up all the resources. Okay. We need to create the cleanup pipeline. So this will destroy all your resources. So this will destroy AKS, this will destroy ACR, so this will destroy MySQL. Okay, all the components will be deleting. Okay, let's create that one. Clean up. Okay, just refresh this one. Okay, this will take some time to delete. So since we have the AKS and MySQL, right, this will take some time. Here you can see all the resources are listing one after one. So destroy is completed. So it will see how the so all the resources are destroyed. See here. Okay. So now go to portal. Data. Okay. Now the cluster itself it is deleted. Okay. Remove this one. Refresh this one. Yeah, all resources are deleted. Okay. So after that you can delete these things also. Okay. you won't require, you can delete this one via pipeline or GUI. You can delete whatever it is. Okay, based upon your convenience. Yeah, we deleted. Okay. So we have completed the pipeline. So conclusion and what's next. So till now we have developed the front-end application and back-end application. So we deployed in AKS. Okay. So we have written the Terraform script. So that will be provisioned using using Infra pipelines. And we have written the Azure pipelines. We have used the Infra pipeline. We have used CI/CD pipelines. And we have used Azure services like AKS and ACR and MySQL. Okay. So we have written Docker files, we have written Kubernetes manifest, we have written the helm commands and etc. Okay. So what's next? So we have a advanced Kubernetes project where you will use the app gateway. Okay. Okay. Thank you. It's yours, Prasanna Kumar, DevOps Technologies.